Okay, in this video we are going to explain about the reactivity of elements in group 1. And to do this we need to understand a little bit about electron structure at the beginning. So what I've done here is I've written down the order of reactivity for the first 3 elements in this group. So potassium is the most reactive, followed by sodium, followed by lithium. And here I've got the electron arrangement for each of these. Now if you're struggling with this to work out electron arrangement, please go and watch the video on electron arrangement to get some help about how to work those out. You should understand that as you go down the group, the reactivity of these metals increases. So the metals at the bottom are the more reactive metals in that group. We need to be able to explain why that pattern exists. And to do that, we need to go back to a little bit of chemistry here, because these elements all contain 1 electron in their outer energy level. This means that they are unstable. And what they want to do is they're all going to try and lose 1 electron. And if they can lose 1 electron, so if they lose this outer electron, they become stable. Okay? So they're all going to try and do that. Now what we need to understand is how easy is it for these elements to lose this electron. And to explain that, I've drawn you a little picture here with 2 examples. I've got lithium here. So here's my positive nucleus for my lithium, and here's my electron arrangement 2, 1. In the energy levels, and then here I've got my sodium positive nucleus, and then here I've got 2, 8, 1 for my electron arrangement. And remember what these are trying to do, they're trying to lose this outer electron in order to become stable. What you need to remember is the outer electron is attracted to the positive nucleus because electrons are negative, the nucleus is positive, and therefore this is holding these electrons in place. But for sodium, what we've got here is there is a greater distance between the positive nucleus and the outer electron. This is in the 3rd energy level. In lithium, it's only in the 2nd energy level. So sodium has a greater distance. Okay, and that is between the nucleus, so between the nucleus, the positive nucleus, and outer electron. And because that distance is greater, that means that the force of attraction is going to be less, and therefore it's going to be easier to lose the outer electron. Okay, so the force of attraction is less, and that makes it easier to lose the electron. And because it's easier to lose the electron, you are going to be more reactive. The other factor to consider is what we call shielding. Let me just jump to a different colour pen, is what we call shielding. So up here we'll talk about shielding. And this electron here is being shielded from the attraction of the nucleus by 1, 2 energy levels. Here, this outer electron is trying to be lost, is only shielded by 1. So in sodium, there is more shielding. And because there's more shielding, that also weakens the force of attraction, making it easier to lose the electron. So the more energy levels you have, the more shielding you have, the easier it is to lose that electron because there's less attraction, and therefore, because it's easier to lose, it becomes more reactive. So when you explain reactivity of group 1, you need to consider 2 parts, the shielding and the distance from that positive nucleus, that attraction to that outer energy level.